Hey, welcome back, everybody. It's time for Making a Connection, the Antaires podcast. Brought to you by the good folks at Antaires. Today we got something, well, it's on everybody's mind. I guess anybody who's out there knows that there's this thing called the Internet of Things, and it extends to the industrial space as well. Here to talk about that industrial Internet of Things is the man who knows everything about it, Henry Martell. Welcome, sir.
Thank you for having me.
You didn't challenge that, so apparently you know a lot. Well, we're going to test that today here because I've been hearing about this for years. Is it finally here or is it still coming? The Internet of Things, where everything or most things or many things in your home, in your factory, in your office, in your business are suddenly connected to the Internet. From your refrigerator to your printer to a dozen other things that you might not think of. Has it gotten that big yet, or is it still coming in the industrial space?
No, it's here. It's definitely here, and it's still growing. So imagine, just 10 years ago, who would ever thought of your refrigerator being online?
Never.
Right,
Never.
So we got smart refrigerators, smart toasters, and it's creeped into the industrial space. So now we have smart sensors, and we have smart gauges that monitor and interconnect to systems that that give readings and that help administrators monitor systems. So we're connected.
Well, the statistic I saw before the show, I looked up and said that the Internet of Things, particularly the industrial Internet of Things, could reach 12 trillion. That's with a T. From the current number of $5 trillion. That's incredible. That means there's going to be that. Is that just the equipment, or is that all the infrastructure that puts it on, like you guys make here?
Well, it's a little bit of everything. It's the whole ecosystem. So, you got one piece that connects to another piece that allows communication to another piece. And so all those pieces together are what's, allowing the growth and the rapid expansion of the IIoT.
So I think of it as manufacturing first. Clearly, everything on the line now, more and more of it's robotic. And all those robotic arms and robotic, you've talked about incredible things, how they pick up perfume bottles and fill them and package them and do all sorts of other crazy things that you've seen. All that stuff is obviously online because it's controlled from somewhere else, right?
Yeah, well, so you got, through automation, you got lipsticks, but imagine a place that processes potatoes, right? You have thousands and thousands of potatoes going through, and you have these little actuator arms that can somehow detect a potato that has imperfections, and it kicks it out, while, hundreds and hundreds are moving through conveyor belts and through different stations.
So it's not just automation. It's not just sending the programming and controlling the programming. It's maintaining this equipment, right? It's not just telling it what to do, but it's keeping it doing it. Talk about that. How does this stuff break down? How does this stuff stop working? All of a sudden, one of the little arms is kicking out the wrong potatoes here or something.
Well, we don't really get involved with that portion of it. Our where we're at in our space is we allow the communication to that actuating arm.
Right.
So, for instance, you have an operator, in the same room or in a different location, the other side of the planet. He's watching sensors and he's watching cameras and he's watching monitors through a connection point, right? You have a network that interconnects to a networking switch. That networking switch interconnects with different cameras and different actuators that allow that to happen. And so if something goes wrong, if there's a fault on our switches, we have alarms and we have indicators that say, hey, this port's bad or there's something wrong that needs to be looked at. And then that relays a message to the operator or to the person involved with that process, and they get a message and they said, hey, we got this port's bad, and that port is connected to this device. That device is malfunctioning, so that's something that we need to look at.
And we've talked about this in other shows, but forgive me for breaking it down this simply. But it seems like it's partly controlling these machines, partly maintaining them so that they're up and operating, and partly knowing what they're doing so that suddenly it's not kicking out a bunch of lipstick or potatoes or something here, and then somebody's got to drive to the factory and go down, or drive to the bottom of the ocean, or go to the bottom of the ocean and look at this thing down there at the bottom of an oil well or whatever. It's sending a human out to suddenly say, well, what the heck, and pull the plug out and see what's happening. I mean, maybe that has to happen, but first of all, you've got to communicate with this and understand what it's doing, right, in real time.
Yeah, in real time. That's the key, in real time, right? So we have all these things moving on a conveyor belt, processing pipelines, right? That's processing oil, wastewater treatment centers where you have millions of gallons of water being processed at a time. So if something goes wrong, right, you need to know in real time what's happening, right? Or even better, you need to know if you can detect things that might be going wrong.
Yeah,
maybe the pressure
there you
sensors are starting to creep up a little bit. Maybe there's we're starting to get delays when we didn't see delays before. So those are all indicators that something might be happening. And that's the best time to catch whatever, a failure or something that's going to go offline, because it's easier to schedule some downtime on a weekend to do some maintenance, to replace an actuator, replace a sensor, replace a motor, versus having it break in the middle of a production run, or have something go offline, when you're processing, water for example, in a treatment center. As you're mixing chemicals or you're moving water around, something happens, and now we got to shut down a plant. And
because this is stuff that can't go down. I can't imagine the cost when the assembly line shuts down, when the oil rig shuts down, when the wastewater treatment plant shuts down. But it's a crisis. So, like you said, maybe you're monitoring and seeing that something's happening. We better address this. Or suddenly something's not working. Can we shut it down? Can we fix it? Can we reboot it? Or we just lose communicate. That must be the worst of all. You just lose communication. You have no idea what it's doing.
Yeah, and those are the ones that, they take time to troubleshoot and try to isolate those problems. Because if we have we're watching our console and we're seeing our sensors and we're seeing our gauges and we're looking at the indicators, and then suddenly something just stops. Well, we have to start from, where did it stop? What broke? How are we going to get there? Right? Who has to be informed? Right? Because in treatment centers or some of these bigger facilities, you got to get a security guard, or you got to get different people to unlock doors. You got to get security clearance to get into certain spaces.
There might not be anybody right there just to call up and say, "Hey, Joe, go over and kick the machine, see what it's doing here."
Yeah.
So, in addition to saving the operation and keeping it up and running, it must be a nightmare when you lose communication. Does it come down sometimes where it's just that? The machine's fine, but we just lost our link to it.
Yeah, that actually happens too, where something happens internally on the switch and we lose the communication portion, but everything that's connected to the switch is working fine. And so we actually have what's called the management portion of the switch, where the operators, the administrators go in and they manage the operations of the switch. They configure a port, or they do something to make some changes. And then you have the devices that are connected to the switch that are communicating back and forth. And we've seen cases in different scenarios where we'll lose the management portion of it, like, hey, we're not getting any feedback, we're not getting any kind of readings, but everything's working fine. And so those get kind of scary, because you don't know what caused the switch to malfunction. You don't know if there's something wrong somewhere. And then at the same time, you don't know if something down the line might be breaking, or something's going on, because we can no longer manage the switch.
And
we
it's
can't see the operation.
Stuff you don't know that you don't know. I don't know what's going on here. That must be panic everywhere. So yes, sometimes it breaks, sometimes it stops, sometimes it malfunctions, and you need to respond immediately and monitor that, which means a good solid connection. Sometimes the connection just goes bad. The machine's still doing it what it is, but you've lost control, you've lost data, you've lost any insight as to what it's doing or any control over it here. So it all comes down to a simple switch. And we've talked about this before. That must be the when you're building a multi-million-dollar, a gazillion-dollar assembly line, or an oil rig, or a wastewater treatment plant here. How much thought goes into that simple switch that's going to connect it to the internet?
In my experience, the data portion is last. Yeah. And I hate to say it, but it is.
I would think so.
So, early on in my career, we did a lot of stuff on the enterprise, where we know people moving into new offices, new buildings, and they would have the furniture picked out. They would have everything done, the color coordination, the carpeting, everything's beautiful. And then someone says, oh, by the way, what about the telephones? Oh, by the way, what about the wireless?
Yeah.
Because everybody thinks someone else is responsible.
Right.
So it's even more, imagine critical systems, right? We're moving into a new facility. We need this to work, we need that to work, but hey, we can't use these particular switches. We need industrialized switches that are designed for dust, debris, vibration, that can take a beating, that can go to extension temperature. And, I hate to say it, but there's been cases where, the connection point is the last thing to be thought of, or in that the bottom barrel of the consideration.
The last thing we're going to think, just go get one somewhere here. Anyone will do. But it needs to survive in terrible conditions, dust, dirt, heat, pressure, noise, vibration. And it probably has to have backups upon backups. And in your systems, you've got a way to manage these things. And maybe even, can you repair them remotely? Can you bypass them? Can you reboot them? Can you do things? I know you get things that, like a ping system that tells people it's still out there. Talk about that. How do you manage that simple switch remotely?
So what we have is we have a software suite that allows administrators to kind of set up parameters that we can monitor the switch. The switch as a whole or the individual ports that it's connected to. So we have our software typically interconnects with corporate software or the customer software that allows the communication that allows the monitoring, right? The bandwidth, the device, the links that are up, down, whatnot, what have you. When things go bad, we know we do get indicators. We also have a way to monitor edge devices. Now, your edge device is going to be your device that's interconnected to the switch. So we have a specific piece of software in our switch that allows, communication testing or monitoring. So if, for instance, we have a camera, a sensor, some type of device that's IP connected, that's interconnected to our switch, and then we lose communication, well, we have an indicator within our switch, within the software suite, that allows administrators to say, hey, this is no longer functioning, please check it out.
Right.
We also have a way to monitor the cable, right? So between our switch...
Yeah. Not just the device, we've talked about that before. The cable, we bought crummy cable. We bought cheap cable. The cable itself got chewed through by a rat or something else there.
Yeah, critters like to sharpen their teeth in our cables. That's just part of the program, But it's, again, we have software that's designed to let administrators know, hey, this is what's going on, and by the way, let's run this software, and it'll tell us within in a certain footage that, hey, we have a break at 70 feet. So we know that our sensor is at the end of a 200-foot run,
right.
And that right around 75 feet there's a breakage because it says that. So then we can kind of walk around and it gives us a general idea of where the fault might be.
Yeah. Otherwise, you're sending people out to just walk up and down the line and figure out where it's behind this piece of equipment. I think it's in that door. No, wait a minute, we moved it somewhere else here, and all that. We'll talk about that at another time, but it goes back to best practices for setting up these things here, because so often people just don't even know where the stuff is. Somebody set it up a long time ago. So all of that comes down to the weakest link theory, right? Mm-hmm. All of this high-tech, high-powered, highly expensive, highly sophisticated, can't ever go down stuff only works as long as it's connected.
Yeah.
And you lose that connection, and you lose control, you lose data, you lose the ability to keep functioning just on the weakest link, the simplest point.
So our switches have specialized connectors. We have a certain line of switches that have specialized connectors that will actually screw in and tighten. So it's good for high vibration areas, or in areas where you don't really think about the cabling, that something might cause a disconnection.
Right.
And if you look at a traditional, an enterprise switch or even our industrial switches, they use a little plastic RJ45 connector that seats into the switch. Well, imagine on a train, right? Or imagine somewhere on a road sign or something with vibration, and after a while, that plastic will give out, and you'll start to lose connection with the plastic pins and the copper pins inside the little the plastic heads for the RJ45 connectors.
Right.
So we have a specialized connector that it plugs in, and then it actually screws, and it's a watertight seal, and that is designed for high vibration areas or places where there's moisture, corrosive gas, that type of deal, and it keeps the pins from disconnecting. So,
well, all of that goes to say the importance of a connector in a world that wants to be completely connected, like the industrial Internet of Things. Give us some examples. What does this future look like, or where are we at today? I know you guys work in a variety of industries. Talk about some of the ones you work in. Agriculture. What's happening out there in agriculture? How does agriculture get connected to the Internet?
Right. So smart agriculture. Who would have thought that agriculture, farming, would be smart and have intelligent agriculture? Right?
I didn't know I had to have a computer science degree to be a farmer.
Yeah. Well, today you do, or at least know a computer scientist.
Right.
So because climate change and a lot of global weather events that are taking place, crops and yields, and the population growth, there's a greater demand for them. And so through smart technologies, we're able to put sensors in the ground to measure moisture content, to measure the pH levels of the soil, and to measuring the growth of your crop that you've planted. And through specialized farming practices, you can now grow more productive yields and bigger crops.
I'll bet.
And more efficiently with less resources.
I'll bet. And they've got drones flying overhead. And you've talked about on another show, one client you had worked with had some sort of specialized strawberry picker that gently found the little strawberries as it roamed through the fields and wild stuff like that, right?
Yeah, so we have this, we have a customer, and they designed the specialized robotic strawberry harvester.
Unbelievable.
And it grows, it's huge, it's massive, it's a sight to see, but it has wheels and it rolls over the strawberry beds, and it has a specialized arm that will come down and gently, that's the key word, gently lift up the strawberry leaves, and then another robotic arm will go around and take images of the fruit. And if it meets the criteria, another arm will come down and crop the fruit. And then it will put it in a little basket, and that basket goes up. And on top of this harvester, there's people stacking strawberries. And what's great about it is this harvester can run 24 hours a day, 7 days a week. It
doesn't take a sick day. Crazy things in agriculture. The one you do a lot with is this whole green technology world here. Talk about that. What's happening in that? I've seen forecasts that say that the whole green tech world might grow to 122 billion within a couple years from the 13 billion that we're at now here. And a large part of that is industrial networking equipment for outdoor communications, right?
Yeah, so we have the green technology, we have windmills, we have all the big heavy technology that we see on the news and we hear in the political world.
Right.
But what I see in green technology is the solar panels, is the solar farms that ranchers are using to monitor crops, watch fences, right? So through industrial application or through industrial networking equipment, we can now set up a pole in the middle of a farm or a stream or whatever we're looking for, set up a solar panel. That solar panel will be charged through the sun rays, and it will actually charge a bank of batteries. That bank of batteries will power our industrial switch, maybe a wireless, and power a camera. Mm-hmm. So in areas where there's no connectivity, or a well or a pump or whatever we're looking for,
still going online.
We're still going online. We can still monitor it. We can still see it. And so those types of applications, I think, are growing exponentially. We're always going to have money for the bigger projects, the big solar arrays, but I see a lot of investment, and I see a lot of people going into the green energy where we're not necessarily connected, but we find spaces to have connectivity.
And like agriculture, these are outdoor environments where you wouldn't think there is any internet connection available or any power to power it, even if you could find it. But that's what you're talking about, solar powering these things. I see the same thing with automotive and traffic industries. I see all these little signs and lights that are just have a little solar array on them here, and that's what's powering them, rather than plugging them into some electrical grid. All that, again, must be connected somehow to the internet because you want to monitor it and control it and change it, maybe traffic lights or different sorts of things. Talk about that. You do a lot in that space.
Yeah, we're really heavy in IT in the ITS space. We have a good presence there. But we'll take the city of Anaheim, for instance. There's, the previous president was here. He was at Angel Stadium, and the place was packed.
Right.
So they had to get people in and out through that traffic congestion. The same thing when we have the major playoff games here. With the Ducks, at the pond, and you have all this traffic that comes in, comes out. And so
they change the pattern. They have like a war room somewhere. I don't know what they call it, but a command center somewhere here.
Yeah, a command center in the Department of Transportation, and it really looks like a command center. You have a bank of consoles, and you have this big, huge monitor wall, video wall with all these cameras, and you can see live traffic. And through sensors, to ground sensors, to wireless, to cameras, they can optimize the lights, and they know how to get people in and out of events really, quickly,
right,
efficiently. And so that's what ITS is. That's the future, right? As more people, are on the road, we're trying to get more safer streets.
In real time, we can really change the traffic patterns through the traffic lights and monitor what they must have sensors in the road or by the side of the road that tell people how many people are coming through. All of that has to be connected or it doesn't work. That command center can't see what it can't talk to, what it can't connect with, right?
Right. And we have our switches that are connected to a box that has miles and miles of fiber optic cable that create big loops within the ground that interconnect back to the command center. That's how we can monitor and manage traffic, accidents, whatnot, what have you, in real time.
So let's talk about quickly some of the current problems in this space. Has COVID had any impact on all this? Seems like COVID's affected everything.
Yeah, unfortunately, COVID has. COVID really took a dent out of the supply chain. It kind of unstabilized it. And so a lot of bigger companies were having delays in getting products shipped and manufactured. So that did hurt our industry just because we're moving along. Supply chain's critical. How we're getting from manufacturing, we're getting it to us, distributors and to customers. And so it did take a dent, and it did kind of have a small interruption. As far as product goes,
and then you got all these global upheavals. We've got war in Ukraine. We've got this new policy and restriction for engineers in China. Talking about that, the whole idea that maybe we're going to try and move semiconductor manufacturing, encourage it to come back here, and penalize it if it doesn't.
Yeah, so that's a big one. That's something new that a lot of people haven't heard of or don't realize yet. That our administration is trying to move forward and trying to bring a lot of that chip manufacturing back to the U.S. just because of the stuff that we've seen in the past couple of years. And so with that process, it's there to encourage our engineers and some of our smartest guys in tech. They go overseas and they make great amount of money and they really help other companies advance their technology. But it's I think our administration is doing a great job of foreseeing that and the opportunity to kind of grow America, right? Bring stuff back. And I know in Arizona they're talking about building some really big plants. Yeah. Same thing in Texas.
They talked about that last administration. They're still talking about the current one. Maybe we've outsourced too far. Maybe we need to start bringing some of this critical stuff back here. So that's what everybody's doing. I just want to touch on a couple of things. These could be shows in and of themselves. The future. Oh, my goodness. You gave me a list of some of these things. I don't know what any of these things are. Talk about IIoT AAS, which means the industrial Internet of Things as a service. Is this virtual, or is this still going to need hardware?
No, it's still going to need hardware. But what happens is we get specialized sensors, we get specialized controllers, we get specialized devices, and what happens is they're expensive, and we need them for critical systems. And so what happens is you'll get this specialized controller, and instead of spending an ungodly amount of money for it, through the cloud-based application, use licensing, and you have access to all these features. And so the features that you want, you have access to. The features that you don't want, you don't really necessarily have to pay for. But it helps smaller companies grow. So we have our widget, we have our sensor that monitors 1, 2, 3 devices, and then as we start to grow, we get another license that goes up to 50 devices, and then it unlocks other features. And those
features come through the internet. So again, they got to be connected to that device because they get added. It's like a software add-on as opposed to another hardware piece, I guess, that you buy. Is that what you're saying?
Yeah. So that's what I'm saying. That's one portion of it. Then another portion of it is, hey, we're a small production company. What we need to manufacture stuff for customers. So we can now hire somebody to kind of do some of the engineering and do some of the connection for us. So we necessarily have to bring everything in-house. We can kind of farm it out and have other people build our stuff and pay for that service. So instead of trying to the R&D in-house, we can get the R&D done. It's been a good cost savings. It's a benefit for the customers in the right application.
A couple more I'm going to throw at you here to see if we can go through them quickly. Digital twin technologies. What the heck is that?
So digital twin technology came about and during the building and the manufacturing of machinery. Instead of building the actual device, we can do it virtually. We can assemble all the pieces, get everything built, and then have it built somewhere else. And so we're actually creating like a digital version of it. So we can look at it, we can test it, we can prototype it. We can do everything that we were able to do in-house. We can do it digitally, which saves money because we no longer have the extra expense of building these devices.
So is it like a computer model or a simulation almost to it?
Yeah, it's into that effect. It's in that realm. further along. It's a lot more specialized.
Well, and the last one I'll throw at you is net zero. We talked about this once before. That's a concept I have trouble wrapping my head around. What's net zero?
So net zero, so think of it this way. When we first buy a product, it's unlocked, it's open, anyone can access it. And then we expect our administrators to lock it down, to add security features and security procedures to it. So net zero is a method of where we sell a product and everything's locked.
Right.
And so if you want something or some kind of feature, we have to unlock it.
Right.
And so what that does is prevents ports or prevents a portion that you might not know was unlocked, and it allows intrusion or some type of
all about
door.
Security, keeping the doors locked here, right? Right. And that's really, I guess, the final takeaway from all this. Isn't this going to be a security nightmare with a million, billion pieces of equipment, sensors? Well, some of them are rather, I guess you'd call them dumb devices. They don't do much. They turn a switch on or off. But now they're on the internet, and that could be a potential point to get into your whole network, because maybe that little piece isn't as protected as your mainframe computers and your other things here.
Right, and then that also leads into artificial intelligence, right? We have machine learning, we have deep learning. We're seeing an exponential growth of that just because, you have small systems, but you might have thousands of sensors and you have all kinds of data. Realistically, it's not humanly possible to monitor all that at once.
Right.
So now we have AI involved, and AI can go out and reach its hands out and kind of make sure that everything's running the way it's supposed to be. We can set some parameters, and the AI can go out and check everything at once for us. If you have 1,000 sensors, me or some of the most brilliant people can't check everything all the time.
No.
So we have AI running in the background that checks everything, that makes sure.
Monitors it, checks it, sees how it's working, and then tries to make sense of this flood, this absolutely fire hose of data that's coming into your systems now here. Because all these little things, it isn't just pushing it out to communicate it, it's communicating back something.
Yeah, so imagine not one, but several fire hoses coming at you at one time.
Right.
And
from every angle.
And you're one man. You might be 2 or 3 man crew, and you got to manage and monitor all this equipment.
Well, it's overwhelming, really, to think about it. But it's here. It's already happened, and it's only going to get bigger, it sounds like, as everything becomes everything in the industrial space, from farming to manufacturing to 1,000 things in between. It's every device in that system is going to become a smart device, like your smart refrigerator, and it's going to start communicating with you and allowing you to control it remotely here and monitor it. And that means it's all got to be connected somehow here and stay connected. And that's to me the miracle of all this. Is all this sophisticated stuff in many cases just comes down to a simple switch.
Yeah, that one little failure point, right? We have all this great technology by brilliant people and designed all this expensive software and hardware, but this one little small switch that interconnects it all together, if that fails, then it kind of the house.
Otherwise, it doesn't talk to each other. Yeah. Otherwise, you don't know what it's saying. Well, thanks you for coming and explaining some of this to us. The future of IIoT, right here on the Antaires podcast. Really, I hope you'll come back and talk about more of this, because it's really fascinating. It has so many different dimensions to it, so many different aspects to it. But it all comes down to some pretty simple equipment, the kind of stuff that you guys make. Fascinating stuff here.
Yeah, well, thanks for having me.
Well, there you have it. Another reason to tune in each and every time to Making a Connection, because that's where it all starts, right here in the Antaires podcast.